All right, welcome to worksheet H10-1 on permutations and combinations. This worksheet should be done after you've finished the notes. This is just a little bit of practice to make sure you're understanding the concepts. So it says here for each item, circle if the order matters or if the order doesn't matter. Then write the correct setup, either n factorial, the NPR, or the NCR for each problem. You do not have to give the correct answer, just show the setup. Okay, so what we've got here, remember, for when order matters, that's a permutation, and when it doesn't matter, that's a combination. So just think about that here, right? Order matters, that means we're circling it, it's a permutation, and if it doesn't matter, that's a combination. Let's go ahead and dive on in here. How many different batting orders can you have with 9 baseball players? Okay, so in baseball, there are 9 spots in the batting order. So if we have 9 spots in the batting order and we have 9 players there, okay, we're trying to figure out the order in which they're batting. So order obviously is going to matter in this one. So when we write this out, right, it's a permutation. We're going to put a P. We have 9 players and we have 9 spots for them. So it's 9P9. Now remember, anytime that N and R are the same value, we can also write that using our factorial. So we could say this is the same thing as 9 factorial. Looking at B, how many seating charts can I make if there are 28 seats and 28 students? So where we're putting the students matters. So when you're trying to make a seating chart there, if I switch any 2 students there, they're in a different order, right? So it's a different seating chart. Therefore, we'll say that this is a permutation. This is 28 students, and we have 28 spots for them there. So in this case here, another one that we can write the factorial. You can't just write the factorial with all of them, okay? And you'll see some up here ahead that you can't. But when N and R are the same value and it's a permutation, you can. So letter C, how many study groups of 5 can I make with 30 students? Well, this is like one of the ones I think we had in the video at the end there, right? So it doesn't matter. There's no specific role within the study group. It's just who is in the study group. Therefore, order is not going to matter. And we would put our C in here. We'd have 30 students to choose from, and we are choosing 5. Letter D, how many different pizzas can I make if I choose 4 cheeses from 7 cheeses? Okay, so the order that we put the cheese on the pizza isn't going to matter. It's just what cheeses we're putting on there. Therefore, again, this is a combination. It's 7C4. Letter E, how many ways can I arrange 15 stuffed animals on a shelf? I always look for that word there. When I see arrange, normally it's going to mean permutation. So I know order is going to matter here. So I'm just taking 15 stuffed animals and I'm putting them on the shelf. So I'm going to have 15P15. And then we're back to one of the ones here that we can write as a factorial. Letter F, how many ways can I make a 6-letter password without repeating letters? This is one that sometimes gets people here. We're trying to make different passwords and things here, and we can only use each of the letters once, so order is going to matter. But when writing it out here, we have to think about, well, we have a 6-letter password, but you need to think about in your alphabet, how many letters do you have to deal with? We have 26 letters to choose from, right? So we're going to say it's 26P6. Now with this one, we will not be able to write a factorial because N and R are not the same. So this one, this is our answer. Letter G, you have to choose 2 out of 5 presidents to write a report on for history class. Okay, so let's say I chose George Washington and Abraham Lincoln to write my report about. Would my report be any different if I wrote it about Abraham Lincoln and George Washington? Right? It's the same report. It's got the same 2 presidents in it. Therefore, order is not going to matter, and this is just a combination. So we've got 5 presidents to choose from, and we're choosing 2. H, your family of 6 is lining up for a photo. How many ways are possible? This is like our lesson where we had 6 books and we were trying to line them up, right? And so therefore, order is going to matter here. And this is a permutation 6P6. or we can say 6 factorial. Letter I. How many juries of 12 can you choose from a group of 50 people? Oops, that's a little typo right there, but it's okay. So we've got there, we're just looking for groups of 12. It doesn't really matter in order. They don't have specific roles. We're just looking for groups of 12. So it doesn't matter. It's a combination. We have 50 to choose from, and we're choosing 12. Letter J. How many ways can 8 runners come in first, second, and third place? So we're not looking for just the top 3 runners. We're looking for specific places, first, second, and third. You know, if Bobby finished first, Dave finished second, and Johnny finished third, okay, that's different than if Johnny finished first, Dave finished second, and Bobby finished third. Therefore, order does matter, right? So then we've got here, this would be like saying 8P3. Letter K, how many ways can I arrange 100 CDs on a shelf? Well, obviously, arrange is in there, so we've got orders going to matter. And this would be 100p100 or 100 factorial. That's a big number. L, how many sundaes can I make if I choose 4 of 8 toppings? Okay, this one order does not matter there. And therefore we have the combination 8C4. Letter M, how many ways can I arrange 34 DVDs on a shelf? Okay, again, that word arrange jumps in there. We know it's a permutation, 34p34 or 34 factorial with that one. And how many ways can I choose a treasurer and a class president from 30 students? So let's say Colin was the president and Vinny was the vice president. Well, that'd be different than if Vinny was the vice president and Vinny was the president and Colin was the vice president. So order does matter because each of those spots has a specific role. So we have a permutation. We're choosing out of 30 students, and the number of students we're choosing is 2, so 30p2. 2 more. There are 100 books in your library. How many ways can you choose 4 books? It's not how many orders can you read 4 books, it's how many ways can you just choose 4 books. Therefore, order does not matter, and it's the combination 100C4. Last one. At a restaurant, you get to pick 3 side orders from a possible 12 choices. How many ways can you do this? Well, if I get carrots, peas, and French fries, it's the same thing as French fries, peas, and carrots. Therefore, order doesn't matter. And we're going to end up with 12C3. If you have questions about any of these, please make sure you reach out to your teacher so we can help clarify anything that's needed. This is worksheet H10-1, the classwork practice version here that goes right after the notes. There is a second worksheet here that you can do on your own and then check your answers on Schoology to make sure that you've got them correct. That would be H10-1 worksheet 2. Other than that, this is all I got for you. Thanks for watching.